Hi there, this is part two of our Beyonce Crazy in Love lyrics study that we're working on. So let's go to StatCrunch to access the data for Beyonce survey number two and see how our data change from the first time that we picked just random 10 words, right, using our own bias or our own meaning of what it meant to pick 10 words versus using a random number generator to pick 10 words. So let's go to StatCrunch and pull up Beyonce number two, the data for the survey. And so we have that here. And let's go to the graph and let's do a dot plot again. And so here's our window for the dot plot. So select the column Beyonce number two, and in this case I do want to put the mean just to see what the mean looks like in the dot plot. So let's compute, and so now it gives me my dot plot over here. So now notice how different this is. Let me make it bigger. Again, we can make it smaller to see the distribution. Sometimes, like I mentioned before, squeezed in, you can tell the shape a little better. So this is definitely skewed right. It has a right tail. Most of the data is concentrated on the left. And the green is our mean. So notice when you hover over it, it tells you what the mean is. So 3.95. Remember, our previous mean was like 4.7. So this is a lot better, 3.95. So let's go ahead and copy this. So let's copy and then right click to copy. So copy the image, and now I can go back to our notes and paste it in there. So now that I have it in the notes, the question is based on this graph. So looking at number 18 down here. So based on this graph, does the random sampling method appear to do a better job than our first method? Clearly explain how you're deciding. So how are we deciding? Yes, notice that the data is a lot more concentrated in one spot. And let's go back and look at what was the population mean. There was it number 10 that told us? Yes, so the for Crazy in Love is 3.59 is the average word length in the 297 words that are in there. So 3.59 is the actual word length. Now remember, we want to know if Beyonce actually wrote the lyrics to Crazy in Love, and we know that her average word length when she was in Destiny's Child was 3.64 letters. And so Crazy in Love was 3.59. So this will suggest, right, that Beyonce also wrote Crazy in Love. But now we're looking at the sampling distribution. So if you take many, many samples from the same population, how close do we get? Now that we got the random number generator instead of our own, we can see that it is much better. It approximates the population parameter way better than we did before. So how did the value of this statistic compare to the population parameter? It is closer to 3.59, right? Our sample mean was 3.95, so let me add that in here. Which is closer to 3.59. 3.59 is the population mean. Estimate the center of the dot plot, so we already have that. So 3.95 is the mean, and the standard deviation was 0.904. So going back to StatCrunch, you can do the summary stats columns to find. So select your column. You want to select the mean, and remember hold control down, and then click on standard deviation. It also tells you here as you hover over, notice the little yellow shows up. Select more than one with shift and click, or control and click. And so I have the mean and the standard deviation, compute, and so here is my mean and standard deviation. So that's what I already put in the notes. So how does your answer from part 20 compare to the population parameter? And we already said 3.951 is very close to the population parameter, 3.59. Definitely closer than our 4.70 was from before, or from Beyonce survey number one. So what does this mean, right? Can we answer the question that was in number 10? do we have enough evidence to say that Beyonce did not write the lyrics to Crazy in Love? And the answer is still no, right? In fact, our sampling distribution suggests support for saying that Beyonce likely did write the lyrics for Crazy in Love, because based on the different sampling methods, there were 22 of you that did the survey, so 22 different samples. Once we did with the random number generator, we got a lot closer to the population parameter, right? The average word length of Crazy in Love, and her in Destiny's Child, the words, the average word letter was 3.64, and so 3.95 is a lot closer to that. So in fact, this then suggests that there's more support to saying that Beyonce did write the Crazy in Love. It doesn't prove it, but it just says there's a higher likelihood, right? The probability that Beyonce wrote the lyrics to Crazy in Love is higher based on our sampling distribution. So that's kind of how this works and what we're doing. So the more samples you take, simple random samples, they can approximate the population parameter. And this is sort of the basis of a lot of statistics, right? If we can take many random samples, simple random samples from a population, and then if they are truly simple random samples, we can say that we can predict population information based on our samples. All right, so in conclusion, when we're sampling from a finite population, we can consider the parameter to be a numerical summary of the variable in the population. So with quantitative variables, like in this case, right, the average word length, we will often be interested in the population mean. So that's the Greek letter mu. With categorical variables, we will often be interested in the population proportion, pi, or sometimes p. I think our book uses p, or you might see pi if you're reading other books. To distinguish these values from the corresponding statistics, we will use the Greek letters mu or pi for the different things. And then for samples, we're going to use x bar for the sample mean and p hat for the sample proportion. So one parameter here is the mean of all 297 words, which mu is 3.59 letters. So we can highlight that. So this is whenever you see a Greek letter, that is our population parameter. And whenever you see an X bar, that is our sample statistic. And so you can kind of read this. So the one in the survey that I asked you about is the proportion of words in the entire song that contained at least one E, and it was 0.3. So you can go back to StatCrunch on your own and see how close were we to the letter E from our sampling distribution. So a sampling method is biased if the results from different samples consistently over or underestimate the population parameter. So Beyonce survey number 1, we can say that that one was biased because it, and then looking back at our dot plot, sorry, I hope I'm not giving you a headache, notice how spread out it was. So this means it was consistently under or overestimating our population parameter. Our population parameter is 3.59, right? So there's a lot of overestimation in here. Once we use the simple random sample, the Beyonce survey number 2, notice how everything was really right around the population parameter, the 3.59. And as I mentioned earlier, right, we won't always have the population. We won't always have the entire population. Like if I wanted to see something about all community college students in California, well, I don't have a way to get my hands on every single community college student in California. But so I can take samples, ARC students, CRC students, right, different Sierra Community College students, different colleges, that can be a sample. And then if it's truly a simple random sample, then I can make generalizations about the population for community colleges in California. But if it's biased, right, if I'm consistently over or underestimating the population parameter, then I can't use that sample. So how can you be biased? We can by poorly designed data collection plan. So in the first survey, I didn't tell you what it meant to be a representative sample. So that was a poorly designed data collection. I just said pick 10 representative words from the lyrics. I didn't give you any direction, so that was a poorly designed data collection plan. In the second survey, I said use a number generator to pick 10 words. So that was a better designed data collection plan. We won't usually know the actual value of the parameter, so we never know the size of the bias, and so we can't correct it unless it's a census. Then we'll know the actual population. The only way to convince yourself and others that your sampling method is not biased is to use a probability sampling method like simple random sampling. So like Beyonce's survey number 2, when we use a random number generator. Keep in mind that bias is an adjective of a sampling method, not of an individual sample. So the key idea here is that when we use simple random sampling, the average of the sample means from different samples equals the population mean, and the average of the sample proportions from different samples will equal the population proportion. So this is a really big deal, but this only happens if we're using simple random sampling. If we have a bias sampling method, we will not get this result. So this means the statistics are unbiased estimators for a corresponding parameter. And so that means that if we are, as long as we're using simple random sampling, we can generalize from our sample, as long as it's large enough, to the larger population. All right, email me if you have any questions.